You send a reel to your friend on Instagram and it shows up instantly. But how does your phone know where to send it? Behind the scenes, your phone is following network protocols. Think of these as the rules of the internet.
Wait.
A network is basically a group of devices connected together to share data. Without protocols, those devices are just screaming into the void. Protocols are the social cues of the internet. Before data moves, it needs to know where it's going. This is the IP address Internet Protocol. It's a unique numerical identifier for your device. Think of it like a home address. You want your pizza delivered to your door, not the neighbor's. This is where the router comes in. A router is the device that connects your home network to the wider internet and directs traffic between them. Your phone doesn't talk to the internet directly. It goes through the router. Your router is the MVP of the network. The GOAT, LeBron James, doing everything. To the internet, your router represents your entire house using a public IP address, basically the front gate to the web. A public IP is the address the outside world uses to identify your network. Inside your house, the router assigns private IP addresses to each device, so it knows exactly where incoming and outgoing data should go. A private IP is the address used inside your network to identify each device. Public IP addresses are limited, so routers allow multiple devices to share one public IP. Now that your device knows where to send data, let's talk about how it actually gets there. There are two main ways the internet sends data: TCP and UDP. TCP, Transmission Control Protocol, is the reliable one. It breaks data into packets, sends them in order, and checks that everything arrived correctly. If something is missing or damaged, TCP will ask for a resend. TCP is like Amazon delivery. Your order gets split into packages, tracked, and delivered in the right order. If one package gets lost, Amazon replaces it. Used for sending messages, browsing websites, downloading files, and email. Overall, TCP is reliable, accurate, but slow. UDP, User Datagram Protocol, is the speedy one. It sends packets without checking if they arrive or if they arrive in order. That means some data might get lost, but the connection stays fast. UDP is like a McDonald's drive-thru. Employees are rushing to serve everyone fast, so sometimes you get the wrong order or missing sauce, but the line keeps moving. Used for online gaming, live streaming, voice calls, and video calls. Overall, UDP is fast and less accurate. Now we need a system that tells your device where to send data. That's DNS. DNS stands for Domain Name System. The Domain Name System is a distributed naming system that translates domain names into IP addresses, allowing devices to locate servers on the internet. In simpler terms, DNS turns human-friendly website names into IP addresses so computers know where to connect. It's basically the internet's phone book. When you type a website like youtube.com, your device asks a DNS server, "Do you know the IP address for this name?" The DNS server looks it up and responds with the IP address tied to that domain. Your device now knows exactly where the website lives on the internet. Important clarification: DNS only finds the address. It doesn't load the website or send any content. That part happens next, and that's handled by HTTP and HTTPS. HTTP, Hypertext Transfer Protocol, is the protocol used to request and deliver web content between your browser and a web server. In simpler terms, it's how your browser asks for a web page like YouTube, Google, or other stuff you like to look at, and how the server sends it back. When you visit a website, HTTP follows a simple request-response process. The request-response process just means the steps needed to ask for data and retrieve it. Nothing is sent unless data is requested first. Your browser sends a request to a server asking for a specific resource, like a web page, image, or video. The server then processes that request by checking what's being asked for and preparing the data. Next, the server sends a response back to your browser containing the requested content. Finally, your browser receives the response and displays the content on your screen. The problem with HTTP is that it sends data in plain text. That means data can be read if intercepted. Passwords and form data are exposed. Content can be modified while in transit. Because of this, HTTP alone is no longer considered safe. It's outdated, like your grandma still using a flip phone. That's why we use HTTPS instead. Hypertext Transfer Protocol Secure. It does the same job as HTTPS, requesting and delivering web content, but it adds security and encryption. HTTPS works by using TLS, a modern security embedded in HTTPS for security, which does three main things. Encrypts the data before it's sent. This turns your data into scrambled code that only the receiver can read. Protects the data while it's traveling. Even if someone intercepts it, they can't understand it. Decrypts it only for the intended recipient. Only the server or your browser can unlock the message. Websites aren't the only thing the internet handles. Email uses its own set of protocols, and each one has a specific job. Email is part of the internet, just like websites. It just uses different protocols. Instead of HTTPS, email relies on its own set of rules to send and receive messages. Each protocol has one specific job, and together they make email work smoothly. There are three main email protocols to know. SMTP sends data. IMAP and POP, 3 receives the data. SMTP, Simple Mail Transfer Protocol, is responsible for sending email. When you press send, SMTP takes your message from your device, sends it to your email provider's server, then delivers it to the recipient's email server. MTP is like an Amazon delivery driver. The driver doesn't open the box, read what's inside, or decide what you ordered. They don't care if you bought those ugly shoes. They just pick up the package from the sender, deliver the package to the correct address, and that's it. But once the package arrives, how do you open it? That's handled by IMAP and POP3, the protocols responsible for receiving email. IMAP, Internet Message Access Protocol, keeps email stored on the email server. When you open your inbox, all of your devices are connected to the same email data on the email server. How IMAP works. When someone sends you an email, it first goes to their email provider server, not your phone or laptop. The email will then be passed and saved on your email server. When you open your inbox, your device connects to the server. The server shows you the current state of your inbox. Your device displays what's there in real time. Even your other devices can receive real-time updates. Nothing is permanently downloaded. It's like twin telepathy. Whatever one twin knows, the other one instantly knows too. This means you can check your email on multiple devices, read, delete, or reply on one device, and every device updates to match. Keep in mind IMAP only downloads your email temporarily through cache when you receive data, and it only syncs your data to all of your devices. POP3, Post Office Protocol 3, downloads emails from the server to one device. Once the download happens, the emails are usually deleted from the server. That means emails live on one device only. Other devices won't see them, no syncing at all. How POP3 works, an email arrives at your email provider's server. Your device connects using POP3. The server sends the email to your device. The email is stored locally on that device. The server removes its copy. Some clients can change their email settings to leave a temporary copy behind. POP3 is old school. It was designed for a time when people had one computer and stayed offline a lot. SSH Secure Shell is a protocol used to securely communicate with and control another computer over a network using commands. It lets your computer securely connect to another computer over a network. It creates an encrypted channel so your communication is private, then verifies your identity with a password or SSH key. Once connected, you can remotely manage the other computer, run commands, and transfer data, all safely with nothing exposed to any nosy Tom trying to peek at your stuff. Before we wrap it up, let's do some active recall to solidify our understanding of network protocols. For each question, pause the video and answer. What does TCP ensure during communication? What is the main job of DNS? Which protocol is responsible for sending emails? Which protocol is responsible for requesting and delivering web pages between a browser and a server? There are a lot of noisy Toms trying to snoop on our private information. If you want to learn the technologies they use to steal your hidden photos or bank information and ways to protect yourself from these Toms, check out the next video.